So we have complete the square to prove the quadratic formula, and we have a quadratic in standard form, which is ax squared plus bx plus c equals 0. So basically what the question is asking us is to complete the square like any other kind of function, and then prove that x will be equal to the quadratic formula. So we're just isolating for x by completing the square by doing this. So what we're going to do is the same thing that we'll do with every other problem where we have to complete the square. So we're going to factor out an a from the leading coefficient of the first term. And then since this is just dividing, factoring that is, it's just going to be b over a, x, and then close brackets plus c equals 0. So we know that now we would usually take this right there, and we're going to half that and then square it. So we know that half times b over a squared could also be written like b over 2a, and then all of that squared. So we're actually just going to write it like that. We're not going to expand it anymore because it's going to be easier to carry it out as the whole thing squared. So it's going to be this, b over a, x, and then plus what we just did, b over 2a squared minus b over 2a squared, close brackets, plus c will be equal to 0. So now what we're going to do is to get that last term in the brackets right here, we're going to get that out by multiplying it by the first term. So we'll do a times x squared plus b over a x plus b over 2a squared, close the brackets, and now we're just multiplying, so we're just going to do negative a times b over 2a squared plus c equals 0, and that's the same thing. A times negative b over 2a, negative a times b over 2a. That's all the same thing, so it doesn't matter the way that you write it. So just to clean it up a little, we're gonna move the portion that we just moved outside the brackets. We're just gonna move that to the other side. So we'll do ax squared plus b over a x plus b over 2a squared, close brackets, is equal to, then since this is negative, we're going to plus both sides of that. So it's going to be a b over 2a squared, and then plus c, so minus c from both sides. So it's going to be minus c. So now that we have that, you can work with the left, you could work with the right. It doesn't matter how you do it because it's just algebra, but it's easier to start working with the right side. But you could also actually, we could simplify the left side as well. Since this is a you can factor this more to a perfect square. You can do a bracket and then x plus b over 2a, and then all of that squared. That's the exact same thing. So then now what we're going to do is expand the squared finally. So b over 2a, what is that squared? That's going to be b times b, which is b squared, over 2a times 2a, which is 4a squared. And then that's minus c. So then we're going to continue writing this, plus b over 2a, all that squared, is equal to, and then we're going to divide out an a now. So if we do b squared over 4a squared divided by a, well, what's 4a squared divided by a? Just that, 4a squared divided by 1a, it's just going to be 4a. So it's going to be b squared over 4a minus c. And we know that c has a denominator of 1, so if we wanted to actually subtract these, then we'd have to make sure that both of these have a common denominator. So we want them to have a common denominator of 4a. So we'll multiply the numerator of c by 4a. So now it'll be written like a x plus b over 2a squared, because you got to continue to carry down the left side. And that's going to be b squared minus 4ac, because it's just multiplying. You can change up the order. And all of that's going to be over 4a, because that's what our common denominator is. So now what we're going to do is divide the a from the left side, just like we did with the right side. So if we divide this by a on this, it's just going to cancel out. And if we divide by a here, divide by a, and we know it has a common denominator of 1. Another way that we can write that is b squared minus 4ac over 4a times 1 over a, because that's how we multiply out our fractions. So that's going to be b squared minus 4ac times 1. It's the same thing. And then 4a squared is going to be what this is equal to, the right side. So we can now write it as brackets x plus b over 2a squared equals b squared minus 4ac over 4a squared. So now, since we have the squared on the left side, and that's where our x is, we're trying to isolate for x, right? So we got to remove it from the brackets, but since this is all squared to the exponent of 2, we've got to square root it. So to do that, we square root the left side. So it's plus or minus the square root of, because every root has a plus and a minus. So it's important that we write that of this. And I'm going to tidy that up a bit. So we've got now x plus b over 2a is equal to the positive or the negative square root of b squared minus 4ac over 4a squared. So now what we're going to do, since we can square root the bottom part of this denominator, because 4a squared is the same thing as 2a if you square root it. So it's going to be x plus b over 2a equals the positive or the negative root of b squared minus 4ac over 2a. And now you can see that this is really similar. This looks very similar, right? So we're almost done. We have one more step. So since these both have a common denominator of 2a, b over 2a, and then the right side has a denominator of 2a, we can simply just subtract b from the other side. So this is going to, x will be equal to, and then minus b over 2a from both sides. It's going to be b negative b plus or minus the square root of b squared minus 4ac, and both of these have a common denominator of 2a. So finally, we have proved that ax squared plus bx plus c, if we complete the square, that will indeed be equal to the quadratic formula.